Hi, this is Mrs. Rodriguez, your algebra teacher. This video is a review for the chapter 10 test that's coming up. So what I suggest that you do is when a problem comes up on your screen, pause the video, do your best to solve the problem, and then see if you got the correct answer. If you did great, move on to the next problem. If not, hopefully my explanation will clear up any misconceptions you might have had. But if not, if you get to the end of this video and there's still a couple of problems where you don't understand my explanation, how I arrived at the answer, please call, text, email me, or stop by my office hours, and I'd be happy to help you. Okay? All right, so let's go ahead and get started. So these questions are from a practice test that can be found on page 667 of your textbook. Okay? So the first section in chapter 10 talks about square root functions, okay, and it contains a square root of a variable, and the parent function of the family of square roots is when f of x is equal to the square root of x, and it starts here at the origin and goes up like so, okay? So it says to graph each function and compare it to the parent graph and then state the domain and the range. Okay, so first thing we have is the square root of x plus y is equal to the square root of x plus 5. So in order to graph it, I'm going to pick a couple of values. So I would start with 0 when x is equal to 0. So that means the square root of 0 plus 5. The square root of 0 is 0, and 0 plus 5 is just 5. So when x is 0, y is going to be 1, 2, 3, 4, 5. So I would put a point there, okay? And then I'd put for positive 1, because 1 is a perfect square. So that would be the square root of 1, which is 1, plus 5, so that would be 6. So when x is 1, y is 6. And then I wouldn't select 2 or 3. I would pick another perfect square, okay, because the square root of 4 is 2, and 2 plus 5 is equal to 7, okay? So when x is 4, y is equal to 7. So I get a really good idea of what my graph is going to be looking like, okay? And it says to compare it to the parent graph. So remember, the parent graph starts at 0 and goes up like this. So it moved 5 units up from the origin, okay? And then it says to state the domain and the range. So the domain, remember, are the x values. So x is at 0, right? We're still starting here. When x is 0, we go up, right? So that's 0. So when x is greater than or equal to 0, and then for the range, those are the y values. So when x is 0, y is 5, right? So it can't be anything lower than 5. So y has to be greater than or equal to 5. So that's my domain and my range. Okay, next problem, number 4. Again, same thing, we're going to graph this function here. So I'm going to pick some values for x and then solve for y. So I'm going to start with -4. And the reason I'm picking -4 is because -4 plus 4 is equal to 0, right? And the square root of 0 is equal to 0. So when x is -4, y is 0, okay? Then my next value I'm going to try is -3. And the reason I'm picking -3 is because -3 plus 4 is equal to +1, and 1 is a perfect square, okay? The square root of 1 is equal to 1. So when x is -3, y is equal to +1. Then I'm going to plug in 0, and the reason I'm picking 0 is because 0 plus 4 is 4, and the square root of 4 is 2. So I'm just picking values that are going to give me an exact value, right? So when x is 0, y is equal to 2. And then I'm also going to plug in positive 5. Why 5? Because 5 plus 4 is 9. And the square root of 9 is 3, which is a perfect square. So 5 up 3. So now I have a very good idea of what this graph is going to look like. Okay? And from the parent function, remember the parent function, origin is here, or it starts at the origin. So what happened is that it moved 4 units to the left. Okay? And then for my domain, remember my domain are my x values. So x starts here at -4. So it has to be greater than or equal to -4. There are no x values on this graph that are less than -4, only greater than. And then my range, remember, are my y values. And y, it starts at 0, right? Because we started here. This point, the coordinates of this point are -4, +0. So my y value is 0, so everything has to be greater than or equal to 0. It's only going to be higher than 0 or equal to, not below 0. Okay, so that's my domain and my range. All right, next section talks about simplifying radical expression. So it's only simplified when there's no radicands have perfect square factors other than 1, and no radicals contain fractions, and no radicals appear in the denominator. And you have to say on the quiz, that was the biggest mistake students made, is that they left a radical in the denominator, okay? So make sure you are mindful of that. All right, so here we've got 3 over 1 minus the square root of 2. So I'm going to, I can't have this denominator, this square root of 2 in my denominator. So I'm going to multiply by 1 plus the square root of 2. My numerator and my denominator. And then when I do that, I distribute that. 3 times 1 is 3, and then plus 3 times the square root of 2. And then I would multiply, use my FOIL method, and multiply 1 times 1, which is 1. 1 times the square root of 2, which is positive square root of 2. Negative square root of 2 times 1 is negative square root of 2. And then the negative square root of 2 times the positive square root of 2 is going to be -2. So I'm going to combine like terms in my denominator, because positive square root of 2 minus square root of 2 is 0. So these are going to drop out, and I'm left with 1 minus 2. So I end up with 3 plus 3 radical 2, and 1 minus 2 is -1. Okay, so I'm dividing by a negative, so I end up with -3 minus 3 times the square root of 2. Okay, I have to divide each of these by each term by -1. Okay. All right, so next problem, number 9. We're simplifying again. So here I would multiply what's outside my parentheses by what's inside. So I multiply the 3 times the 5, and that's 15. And then the square root of 6 times the square root of 2 is the square root of 12, okay? Now I can break down the square root of 12, because there is a perfect square of 4, because one of the factors of 12 is a perfect square. 4 times 3 is equal to 12, and 4 is a perfect square. So the square root of 4 is 2, and then I'm still multiplying by the square root of 3. So 15 times 2 is 30, and then I still multiply by the square root of 3, and then that's as far as I can go, okay? And then this is an additional practice problem. So it's not in the practice quiz, but you will have one very similar on your test. Okay, so remember when you have a fraction underneath a radical, the numerator is under the radical, and so is the denominator. Okay, so 50 has a perfect square factor, right? 25 times 2 is 50, and 25 is a perfect square. And then the square root of a squared is a, right? A times a is a squared. And then the square root of 25 is 5 times the square root of 2 over a. Okay, so that'd be our final answer there. And then here, operations with radical expressions and equations. So radical expressions with like radicals can be added or subtracted. Okay, and then you can use the FOIL method to multiply radical expressions. Okay, so here we're adding and subtracting, but remember they have to be like radicals. Okay, so we have to look at each one of these terms and see if any of them have a perfect square factor. Well, the square root of 6 does not. Okay, so we leave that as the square root of 6. 54 has a factor of 9, because 9 times 6 is 54, and 9 is a perfect square. And then we have 3 times the square root of 12, and 12 has a perfect square factor of 4. 4 times 3 is 12. And then 3 does not have a perfect square factor. Okay, so what I have now is the square root of 6 minus the square root of 9, which is 3, times the square root of 6, plus 3 times 2, right? The square root of 4 is 2. So that would be 6 times the square root of 3, plus 5 times the square root of 3. Okay, so now I have some like radicals, right? I've got the square root of 6 minus 3 times the square root of 6. So that's 1 minus 3, which is negative 2, times the square root of 6. And then 6 times the square root of 3 plus 5 times the square root of 3 would be 11 times the square root of 3. Okay. All right, and another additional practice problem, you will have one like this on the test. You have to use the FOIL method here, okay? So remember the first term would be 2 radical 3 times radical 10. So that would be 2 times radical 30. And then the outer terms, 2 times 4 is 8. And then radical 3 times radical 6 is radical 18. And then the inner terms, negative radical 5 times radical 10 would be negative radical 50. And then my last terms, negative radical 5 times 4 radical 6 would be negative 4 times radical 30. Okay, so then in order to add these or combine any of these, I need to see if there's any perfect square factors in any of these terms. Well, radical 30 does not have a perfect square factor, so I would just leave it like that. But radical 18 does, because 9 times 2 is 18, and 9 is a perfect square. And 50 is 25 times 2. 25 is a perfect square. Minus 4 times radical 30. Okay, so now I have some like radicals. I've got 2. Oh, let me take a step back here. Let me simplify this. So I've got 2 radical 30 plus 8 times 3, right? Square root of 9 is 3, and 3 times 8 is going to be 24 times radical 2 minus square root of 25 is 5 times radical 2 minus 4 radical 30. So I've got 2 radical 30 minus 4 radical 30, so that's negative 2 radical 30. And then I've got 24 radical 2 minus 5 radical 2. So that would be positive 19 radical 2. And that would be my final answer. So the next section talks about radical equations, okay? So if you square both sides of a true equation, the resulting equation is still true. Okay, so once you get everything around the radical to the other side of your equation, then you can square both sides and then solve your equation. So here we don't have anything around our radical, so I would square both sides, and then 10x times 10x, radical 10x times radical 10x would be 10x, so it just basically removes radical, and then 20 squared is 400, and then I would just solve this like a regular equation. So x is equal to 40, and that would be my final answer there. Okay. Okay, problem number 12. Here, again, I don't have anything around my radical, so I would square both sides of my equation. So that drops off this radical symbol. So I get 4x minus 3, and then I have 6 minus x times 6 minus x. So I use my FOIL method. So I've got 6 times 6, 6 times minus x, negative x times 6, and then negative x times negative x. So I end up with 36 minus 12x plus x squared. So I'm going to write that as x squared minus 12x plus 36. And then I'm going to solve this equation. So what I need to do is I'm going to add 3 to both sides. And I get 4x equals x squared minus 12x plus 39. And then I'm going to subtract 4x from both sides. And I get 0 equals x squared minus 16x plus 39. Okay. So what I'm going to do is factor this here. So I need the factors of 39 that add up to negative 16. So that would be negative 13 and negative 3. Okay, because 13 times 3 is 39, and negative 13 plus negative 3 is negative 16. I put my x's in front, and then I'm going to solve each of these equations. So I've got x minus 13 equals 0, and x minus 3 equals 0. So I would add 13 to both sides, and I get x equals 13. And then I would add 3 to both sides, and x is equal to 3. Now we have to account for extraneous solutions here. So I'm going to plug in x equals 13 to my original equation. So that's 4 times 13 minus 3. And see if that's equal to 6 minus 13. So 4 times 13 is going to give me 52. So I've got 52 minus 3. And 6 minus 13 is going to give me negative 7. So 52 minus 3 is going to be 49. And then the square root of 49 is equal to 7, which is not equal to negative 7. So that's not going to be one of my solutions. Okay, so then I'm going to input x equals 3 into my original equation. So 4 times 3 minus 3, the square root of that, and then 6 minus 3. So 4 times 3 is going to be 12 minus 3. 6 minus 3 is 3. 12 minus 3 is 9. The square root of 9 is 3, which is equal to 3. So then that is my solution. X is equal to 3. All right, and then the next section talks about the Pythagorean Theorem. Okay, so that's when e squared is equal to a squared plus b squared. Okay, So this is an additional practice problem here. It says determine whether each set of measures can be the lengths of the sides of a right triangle. So I'm going to use this as A, this is B, and this has to be C. Okay, remember C is always the longest side. I could use 16 as A and 12 as B, doesn't matter. But I'm just going to do it in the order it was given to me. So I'm going to put 12, well, recall it's going to be C squared is equal to A squared plus B squared. So C is 21, A is 12, and B is 16. So 21 squared is 441, 12 squared is 144, and 16 squared is 256. That 441, and if I add 144 and 256, I get 400, and that is obviously not equal to each other, so no, this is not going to be a right triangle, okay? All right, and then another problem just like this, I'm going to call this A, this B, and again, 13 has to be C, the longest side has to be C. Okay, so I've got C squared equals A squared plus B squared. So if this is a true statement, then yes, it would be a right triangle. But if it's not, then it's not going to be a right triangle. So this is going to be 13 squared is 169, and 5 squared is 25, and 12 squared is 144. And if I add 25 and 144, I get 169, which is equal to 169. So yes, this is going to be a right triangle, okay? Okay, here it says to find the missing length, okay? So obviously my missing length is C. So I've got C squared, this is a right triangle, so I'm using the Pythagorean Theorem. So I'm looking for C, I'm gonna call this A, and this B. So this is 6 squared plus 8 squared. So this is 6 squared is 36, 8 squared is 64, and when I add 36 and 64, I get 100, and what I need to do is find C, so I take the square root of those sides, and I get 10. So C is equal to 10. And number 15, again, this is a right triangle. I'm missing one of the sides, so I'm using the Pythagorean Theorem. C squared equals A squared plus B squared. So C now is given to me, so that's 10. Remember, that's the hypotenuse where the right angle is pointing, or the longest side. And then I'm going to use 4 for A, and B is what I'm looking for. So I've got 10 squared, which is 100, 4 squared, which is 16. So I'm going to subtract 16 from both sides. When I do that, I get 84 equals B squared. I want B, not B squared, so I take the square root of both sides. I punch that into a calculator. Do not expect you to figure that out, okay? And the square root of 84, when you round it to the nearest tenth, is 9 2/10. Okay. All right, number 16 says Ben and Amato are delivering a freezer. The bank in front of the house is the same height as the back of the truck. They set up their ramp as shown. What is the length of the slanted part of the ramp to the nearest foot? Okay, so it's asking for the length of this here. This is obviously our right triangle, so this is our hypotenuse. They're asking for the value of C, okay? So since we have a right triangle, we know 2 of the lengths of the legs, we're going to use the Pythagorean Theorem. So we're looking for C. We can use 6 2/10 as A, and 3 5/10 as B. When we do that, 6 2/10 squared is 38 44/100. 3 1/2 squared is 12 25/100. When you add that together, you get 50 69/100. And then punch that into your calculator, take the square root, and you're going to round to the nearest foot. And when you do that, you get 7 feet. Okay? All right, next problem. Oops. Says find the values of the 3 trigonometric ratios for angle A. Okay, so here's angle A. Okay, so we're talking about angle A, right here. So we want the sine of A, the cosine of A, and the tangent of A. Okay, so sine, remember, is the opposite over hypotenuse. So the opposite is going to be 4, and then the hypotenuse is 5. Okay. For cosine of A, remember that is adjacent over the hypotenuse value. So adjacent, it would be right here at 3, and again, the hypotenuse is 5. Okay. Tangent is opposite over adjacent. Okay. So opposite is 4, and then adjacent is 3. Okay, so those are our 3 values there. Okay. So here, this right triangle says to find the measure of angle X. Okay. So we're looking for this angle here. Okay. Well, we're looking for that angle, and we have the opposite value, and we have the hypotenuse. Okay. So that is the sine. Okay. So we want the sine, and that's going to be opposite, which is 9, and then hypotenuse, which is 15. Okay, and we want the degree, right? So we want the inverse sine of 9 over 15. You punch that into your scientific calculator, or you can use Desmos, DESMOS.com. It's a free scientific calculator online, and you plug in the inverse sine, okay, and you put 9 over 15 in parentheses, and you end up getting 36 and 86 hundredths, and you round that to the nearest degree, and you end up getting 37 degrees. Okay. And then last problem says, how tall is the lighthouse? Okay, so we can see from the diagram here, we have a right triangle. Okay, just trying to get you to see that, right? The right triangle there. Okay, and we know the length of this side is 25. We don't know the length of this side. That's what we are looking for. And we know the length of this angle is 79 degrees. So it's really hard to see on that diagram. So I'm just going to do it over here. We're looking for this side. We know this is 79 degrees, and then here is 25 feet. Okay. So we have the opposite over adjacent, okay, of this angle here. Okay, so opposite over adjacent, okay, and that is going to be tangent, okay. So we have the tangent of 79 degrees is equal to the opposite x over 25, the adjacent, right? So this is an equation. We need to isolate x. So x is being divided by 25, so I'm going to multiply both sides by 25. So 25 times the tangent of 79 degrees is equal to x. So I type that in the calculator, 25 times tangent of 79. And when you do that, and you round to the nearest tenth, you get 128 6/10 feet. That is the height of the lighthouse. Okay. All right, so hopefully this video was helpful to you. Hopefully it answered any questions that you may have had or any misconceptions you may have had. If you still are at this point in the video and you didn't understand any of the questions, please call, text, email me, or stop by my office hours and I'll be happy to help you. Okay, you have a great day and good luck on your test.